Okay, folks, we should get started because our time is been cut a little bit short, a lot short, actually. And in typical style, I've scheduled 8 hours worth of stuff for 1 hour, and now we're down to a half an hour. So I'll either talk really fast, and we'll get through it all, or we'll just get as far as we can. Before I start, I just want to say that I am very happy to share anything that I have. If you all want the PowerPoint, that's fine. Materials I refer to or activities we do. I don't need it, but do you want me to have it? Yeah. Okay, there's so few of you, I feel like I can talk without the mic. But so anyway, as I was saying, activities, PowerPoint, articles I might refer to, any of that, I'm happy to send to you. I'll give you anything I have with me, but anything I might refer to or whatever. If you give me an email address, I'm happy to share anything with you. And to follow up, because we certainly aren't going to have the time for some of the discussion that I think is so valuable, actually. So let's start by, I guess I'll start by just introducing myself. I'm Judy Laird, and I'm here from the States. I live in a very cold and snowy place called Vermont. I left Vermont and it was way below 0 Fahrenheit, that would be, and it was snowing, and I think at my house we have about a foot of snow already, and much more to come. It just doesn't go away until about March or April. So when I landed here in Jordan, what seemed like 2 days of flying later, it was wonderful to see the sun and the warmth. I'm just so excited to be here. It's my first time in your country, and it's beautiful. I enjoyed the 1 day that I had yesterday, although I slept much of it. My background is as a teacher. I was a math teacher for 15 years. I started in the 1st grade, taught some 4th grade, but primarily consider myself a middle school teacher. From teaching at the middle level, I became what we call a math coach in Vermont anyway. There's a lot of different terms for it, but I became a coach for a pretty large, geographically large district. Nothing is large population-wise in Vermont. Our whole state is about 600,000 people, so it's a pretty small state, but geographically it's quite rural. And so I did a lot of my teacher, leader, coach work in a pretty rural school district. I left teaching to become an assessment consultant for our State Department, and then I went on to help start and continue to run what's called the Vermont Mathematics Initiative out of the University of Vermont. And I guess I want to start, before we jump into any of the mathematics, I want to say I am not an expert at anything. I think I've had the good fortune of having great mentors along the way, and I've had the good fortune of collaborating with some phenomenal teachers over the last 15 years. And so what I share with you is certainly information from research and from the things I have learned from the reading and the work that I have done, but certainly, probably more so, what I share with you comes from all of the collaborative interactions that I've had with some phenomenal teachers over the years. Let's see. There's a lot of things we could talk about when we talk about math for primary kids. I chose to talk about this idea of relational thinking. And one of the reasons that I chose that, amongst the probably many things that I could have talked about, is if you take a quick look at the research around algebra, we realize that very early on, students have the innate ability to think relationally about numbers, which we'll talk about a little bit more. And really that's the foundation of thinking later on about formal algebra. So in the States, I was saying earlier that we are transitioning our approach to algebra much to the way that we're going to talk about today. We have done a lot with patterning over the years and had patterning leading to algebra. And what we realized is that
if we really looked at arithmetic and the way in which numbers relate and work with one another, and help kids at a very young age understand properties of numbers. Those properties don't change whether we're talking about an X variable or whether we're talking about basic arithmetic. So we're going to start by with this topic of relational thinking. We'll get as far as we can. I want to start with a very basic, just a very basic definition for now. Students who can express a number in terms of other numbers and operations on those numbers hold what we call a relational understanding of the number. Put simply, thinking relationally means that we're looking at mathematical relationships in order to solve some problems. Let's look at some stuff and some problems here. I obviously had hoped to give you a bit of time to look at a bunch of these, but if you maybe as a table could just turn and take a look at maybe 2 or 3 of these. I'll only give you about 3 minutes or so to take a look at some of these and chat about them. But I want you to think about how a student might use relational thinking, and I understand right now that definition of relational thinking might be a little bit vague. But how might a student think about when they respond to these? And keep in mind that they aren't all true. Some of these sentences are false number sentences. Why don't you take, 3 minutes and just have a little chat about how you think students might attack some of those. Okay, I'm sorry to cut it short. These are actually quite fun to look at and to think about all the various ways that kids might actually, that not only kids, but adults might look at some of these number sentences. By looking at these, are you beginning to get an idea of how we're using relationships in order to look at these number sentences? Okay. Let's take a look at this. How might you, again, just have conversation. How might you rank these from easiest to most difficult? And I'll put them all up there. Just again, just another minute or so. What do you think? Yes. Yeah. From easiest to most difficult. Think about it. Okay, I'm going to keep going or we won't even get to the meat of the presentation. And I'm not intending to go over these one by one, but again, just to get you thinking a little bit about how we look at relationships in terms of some of these numbers. But what I really want to do is go backwards a little bit and talk about why. Why should we think about relational thinking, and why should we work hard to try to build this with our students? I think the answer lies in some of these bullets. Perhaps, probably, this is not inclusive, but certainly it facilitates children's learning of arithmetic. When we can think about the relationships between numbers or amongst the numbers in a number sentence, we can avoid memorization and instead work on what we know about these numbers. So we get a deeper understanding of what's going on with arithmetic. Algebraic reasoning is bound with learning arithmetic. So as I said earlier, some of the very basic ideas around algebra really start early on here with this idea of relational thinking. And finally, we're going to smooth the transition to formal algebra. I was saying earlier, oftentimes when a child enters algebra class, we say, okay, now we are starting from scratch. We are starting this brand new thing called algebra. And we think we're starting with nothing. And what we really should be starting with is what's come before. All of the deep understanding about arithmetic, about relationships, about properties of operations, all of those things start very early. And we're really now just transitioning into a more formal study of algebra. So relational thinking has benefits. It's about the way in which a child thinks that's going to smooth their math experience along the years. I also would say that I believe it makes algebra and mathematics more accessible to more students. So those students who struggle particularly, who maybe struggle to memorize or struggle to do some other things with mathematics, if we can teach them how to look at numbers and look at mathematics relationally, I think we can reach more students and we can make the topic of algebra accessible to more students. What I want to have you do is take the baggies that I just passed out, or that Faraz just passed out for me. Thank you. And I'd like you to just look at some things. So we're backing up a little bit. This would be before we put numbers to things. And we're giving kids some strips, and they're varying lengths, okay? A couple of them you might have to unfold because they wouldn't fit in my baggie. But I'd like you to take a look at these without assigning numbers to them. So envision your students just kind of playing with these strips of paper. And I'm wondering, how might you describe them individually? And how might you describe their lengths comparatively? So if you kind of compare a few of them, how might you describe them if we don't allow numbers to be attached to them? And then the meat of this activity, and I'd like to give you, I had hoped to give you 15 or 20 minutes, but that would run over the time. So I'm only going to be able to give you about 5 minutes to play with these strips, but I hope it gives you an idea of some of what you can do with them. But what I'd like you to do is just use some of the lengths to compose different lengths. I'd like you to use the lengths to compose equivalent lengths. And by the way, I have many more, so you can work together on this. You can use more strips from up here if you need them, but use the length to compose some equivalent lengths. Decompose a length into 2 lengths, or 3 lengths, or 4 lengths. And then use the lengths to find similar differences. And don't let this constrain you as you explore with these strips. As you're working, what I'd like you to be thinking about is what is the underlying mathematics, the underlying big ideas that transcend this activity that we can experience with these materials. So go ahead and play with these, using these as starting points. And unfortunately, in 5 minutes, I'll have to pull you back together and probably tell you some things rather than have you experience them.
Would you like a bag?
Yeah, are they like Cuisinart?
Maybe, yes.
Can I play with you?
Sure.
It's nice to have you here. Thank you. Did you have a nice lunch with him too? Did you? When did you come in? Oh, gosh. At least came in a day earlier.
Where?
Staying at the Marriott. Are you?
Hello, how are you?
To meet you.
Thank you.
We're very proud of you in the state.
Oh, I should say
We really enjoyed it. It was very beneficial.
Remember that the idea here is that we're trying to teach or encourage a way of thinking, not necessarily an algorithm.
Just to be a kid and play. The hardest part is moving them around, isn't it? Picking them up. Yes, I realize that myself.
Expensive stuff like to do this, but it's much easier to come in.
I could have just brought the queen there.
Well, that equals blue. Should be a blue and yellow equals green.
Sure, just no right or wrong. We're just looking at relationships and mathematical big ideas that kids might encounter. Did you want to play? Yes, you can play this one.
I'm sorry, I have to cut this a lot shorter than I wanted to. Continue to play while I speak. It's absolutely fine by me. But I'm wondering if even just with that very short time that I gave you to kind of play with some of these materials, what are some of the larger mathematical ideas that you think kids would encounter, obviously through some questioning by the teacher and maybe some scaffolding of the activity a little bit. But what are some of the big ideas that you think might emerge?
Equivalence.
Equivalence, absolutely.
Relational thinking between the shapes.
Sure. So relational thinking between the shapes, for sure. Yes. What else?
have related to the meter concept of the shapes. This is what I thought that links it
So say-
related to shapes also.
Okay,
Not
oh, okay.
only for equivalent numbers.
Okay,
Relationship.
okay. Anything else?
Decimals? Decimals?
Ah, nice, nice, absolutely. We can begin to look at decimals, or I might make that even bigger and say parts,
And I think fractions.
fractions, absolutely.
Because it can be one or one, two half or.
Right, and what is our whole, we can talk about, absolutely. Did you see some of the properties of operations emerging? For instance, the commutative property, the idea that, you know, if I gave you enough of these and if I gave you long enough to play with them, kids come to this idea that a red and a green is the same thing as a green and a red. Okay? But I'm not putting numbers to anything. We're exploring, we're playing, I'm asking good questions as kids are doing this work. How about part-whole relationships? That idea that a whole is made up of parts. Okay? So, and that idea in mathematics we often call decomposing. So I can take a particular length and I can decompose it into other lengths. Somebody said equivalence, but I guess to expand on that a little bit, we probably, as I was walking around, I could see many ways of making the same number or the same length in this case. Now I'm saying numbers. Okay, let's see what else I've got here. Oh, how about the relationship between adding and subtracting? Again, I might need to do some questioning in order to lead a child there. But I think it's a great way to begin to look at inverse operations. And when I put something together, I can take it apart, and I'm back where I started. So that inverse operation can be explored here too. This activity, although very, very simple, has a lot of potential in terms of helping children around a way of thinking around mathematics. Okay. I don't particularly like to read slides, but in this case I am going to read a little bit to you here. Probably the major conceptual achievement of early school years is the interpretation of numbers in terms of part and whole relationships. With the application of a part-whole schema to quantity, it becomes possible for children to think about numbers as compositions of other numbers, which is really what we were just doing, only we didn't exactly put the numbers to it. Okay? Composing and decomposing numbers is another approach to addition and subtraction. And again, opens up, I think, possibilities for students so that we aren't always memorizing everything, okay? I want to take a look at one more idea here that falls under this idea of relational thinking. So we've looked a little bit at properties of operations, we've looked at part-whole types relationships, decomposing, composing, all of those things kind of fall under this big umbrella of relational thinking. Everybody ready? The question is, how many? How did you see that? Did you see it as 3? Or did some of you see a 2 and a 1? Or a 1 and a 2? Just 3, the shape? Okay. Ready for the next one?
5.
Did you see it as 5?
4
4 and a 1? Okay.
Yeah,
4 and 3? Everybody said that, okay. Five and 4 in the back. How did you see that? You saw the 5 and the 4. So you saw the inside first and then the outside. Oh, okay. So what did I just have you do? I had you quickly determine the quantity of a small number of objects without counting. And I gave it very quickly without counting. It's called subitizing. Subitizing is a fundamental skill in the development of students' understanding of number. And again, can you see this idea, in a way, of this composition and decomposition, the way you saw some of these things. Ready? They're going to get a little harder. 12. How did you see that?
4 times 3.
Okay.
3 times 4.
3 times 4.
3 times 4.
Okay.
5 times 5.
You're quick.
25.
25. You saw 5 groups of 5.
5 groups of 5.
Okay. Whoop. Yeah, that might have been a little too quick, but how did you see that? For those of you who
2
are-
groups of 6. 2 groups of 6.
Oh, okay, 2 groups of 6, wonderful. 3 groups of 4, so you saw it by the rows, okay. Okay, great. The last one is just, I just want to kind of show you where some of this goes a little bit. Ready? Remember, you're trying to tell me how many in all, and I am not showing all of them this time.
It's multiplication, but we didn't see. 6 times
6
5
times 4.
and 4. Okay.
6
Yeah,
times 4.
I probably should have left it a second or two longer there. Obviously, the idea with studentizing, whenever you do an activity like this with kids, is you want it to flash quick enough that they can't count it, but long enough so that you can actually see something, right? I want you to see these groups. There's a, well, let me just go to the next one.
And 4, 32.
I'll just put it up. One of the reasons that I'm kind of putting you through this activity, besides the idea that it falls under this idea of relational thinking, again, and helping kids to see numbers in terms of parts that make up that number. But the other thing that's happening here in this second set is that we're beginning to look at this idea of a unit being more than just one. So now we're looking at a unit that's consisting of 4 dots in this case. So 3 different units of 4.
I think it's interesting. Can you go back to that?
Sure.
I think it's interesting, though, that you would not say 4 groups of 3.
Yes.
Because the display is different, maybe.
Right.
If we display them in a different way, we can see them like this.
Right.
That's why we ask children sometimes, we give them dices, and we ask them to put them in different ways and find many operations according to one set of numbers. Because they can find maybe not multiplication, maybe addition or...
Right.
Various ways to get the answers, right?
This idea of unitizing is huge. And I find it very interesting that unitizing is a huge shift for children. Up until this point in time, 1 meant 1. 1 didn't mean 4. And so this is a huge shift, and in fact, took centuries for us to kind of come up with this system, but yet we're wanting kids to come up with it like overnight. So I think we have to acknowledge as educators, this is a huge shift in thinking. This idea of unitizing, and the idea that 1 can actually mean 4 in this case. And obviously underlies our place value system, our base 10 system. Okay.
So we used long time ago to teach not only base 10, we used to teach children base 5 or 4
Yes.
or 3 or 2. That's long time ago, but after we changed it because we saw that children are confused with all of these numbers who doesn't say the same thing.
Yes.
That's why we removed it a long time.
I work with a lot of my colleagues in the math department at the University of Vermont who are mathematicians. I'm not. I'm a math educator who happens to be in the College of Mathematics. And it's very interesting the conversations that we have. And every one of them will tell me that when children struggle, when students at the university struggle with algebra or calculus or some of the higher level mathematics, that they aren't really struggling with the calculus. What they're struggling with is the arithmetic and the perhaps some of the basic place value and basic understandings of mathematics that occurred way earlier on. And so by speaking with the mathematicians there, I think that, what I'm learning, what they would say, what they tell me is that some of the most critical educators are the educators at the primary grades. Because when they're seeing their students struggle at university, it's never about that topic. It's something that came earlier. So I think some of
that comes from parental pressure, of course, because the children who are going on to become students at university, maths are obviously very capable and pick it all up very quickly, except they've not really got the concept built in, because they're not doing it, they go straight on to the abstract work, which they can get away with at a more basic level, but not when it gets to university.
Exactly. And then the university folks tell us that it's hard to kind of go back and fill that gap. Okay. Okay. I'm just going to quickly finish up so that you don't miss your coffee. I really apologize. I feel like I talked really fast and got through about half the slides. But let's go to the end, and we'll at least get to the moral of the story. I think the implications for teaching and learning, and again, had we had the hour, I believe that many of these ideas would have come from you. I think you would have seen it through the activities that we would have engaged in. So I apologize about that. But I think we should be using tasks in our work with children that allow us to promote a way of thinking, a relational way of thinking, as opposed to an algorithm. So that when those children get to formal algebra, we aren't starting with a blank slate. We are starting with some very important fundamental knowledge. And now we're just throwing some X's and Y's and Z's on top of that. Okay. As students share ideas, as they share their approaches, as they listen to others, I think the emphasis for us as teachers is on the way in which they're thinking relationally. How is it you solved that quickly? Those types of questions that are going to encourage this relational thinking instead of what's the answer. We want to know the answer, but I think, again, we want to know how they're thinking about it. We want to help them use the relationships to make the mathematics a little easier. Let students manipulate materials and create models to support their understanding. These are some models. Cuisenaire rods are some models. The subitizing activity are some models. There's a lot of different models, and there's a lot of different ideas that fall under this idea of relational thinking. The tasks that students engage in significantly influence what they learn, but equally important are the interactions that they have about those tasks. So it's not enough, obviously, for me to just throw strips of paper at students and think that they're going to walk away with the ideas of commutativity, associativity, and some of those. That's the part that's on me, the questioning and the activities I put in front of them, the wrap up, those types of things. Use questions that focus on the important mathematical ideas. Again, we want to know an answer, but I don't think that the most important question is what's the answer. I think that the most important questions are questions like this. Is it true for all numbers? How do you know that it's true? How did you look at this problem to know that it was true or false, and so on and so forth? Okay? Relational thinking is a defining feature of learning with understanding. Knowledge is connected, it's integrated. Students make sense of new things, as we heard earlier, by connecting them to what they already know. Developing relational thinking with arithmetic serves as a basis for learning algebra. As I said earlier, we're not starting with a blank slate, we're starting with quite a bit when kids come to formal algebra. And I think one of the biggest things is that primary students can engage in algebraic thinking. And we've sold them short for far too long. They come with an innate ability to see and work with a lot of these important mathematical properties. They just don't have the formal name to those properties at those early grades. Relational thinking activities opens up opportunities for all students, I believe, to interact with the important ideas that transcend all the domains of mathematics. So I think It's pretty important that we begin to think about it, that our questioning, again, promotes this idea of relational thinking. Relational thinking emerges early in children's thinking. Most children use some form of relational thinking to solve addition and subtraction problems by the end of the 2nd grade, even in classrooms where the teacher doesn't focus on it. But the key here, this is why teachers matter. Without teacher guidance, children do not continue to develop their capacity to think relationally. And so, as we see in many cases, that ability to think relationally kind of falls apart. It goes away if it isn't fostered by the teacher. And that seems to have happened, at least for many of our high school students. And the students begin to abandon that idea of making sense of the mathematics, and we start to grab algorithms. And then we start to kind of weed out the kids who can memorize the algorithms will go on, and the kids who can't won't. So relational thinking, I think, opens up the world to more students, as I said when I started. Again, I really apologize for how fast and how much you didn't get to kind of work with the materials and some of the activities that I had for you. But I do thank you for coming for the half hour. I'm happy to send you anything more, and I'm happy to communicate email with anybody in order to help maybe think a little bit more about this topic. I think there's coffee out there for you all. Thank you.